Okay, so this is going to be an instructional video for problem 26 from chapter 33 of Physics for Scientists and Engineers. Problem 26 is asking about the magnetic force on a moving charge, in this case being a proton. And it has two situations, and it gives you the velocity vector and the magnetic field vector for this problem. So first we're going to do the part B because it's easier to think about. So normally we'd use the right hand rule here, where this finger is the magnetic field, this finger is the velocity, and this finger is the resultant force from these two. And so we try and do this here. It's kind of awkward. The magnetic field is my middle finger and the velocity is my pointer finger, but it's kind of awkward because they're 180 degrees apart. So let's go on and look at the angle between them to try and see which way the force is going to be. So the angle between them is 180 degrees because they're straight along opposite directions. So now let's go to the equation that we would use to find the force, which is F equals Q V cross B, where Q is charge, V is velocity, B is magnetic field. Now we look at the cross product, V cross B, which is equal to the magnitudes of the two vectors times the sine of theta, where theta is the angle between the two vectors, which we already determined was 180 degrees. But now, of course, we look at that, and the sine of 180 degrees is 0, making the conclusion that there is no magnetic force on the proton, F equals 0. So now let's go over to part A. We have our givens here. We can just look up the charge on a proton. But here it's a little bit different because the angle between the two vectors, the velocity and the magnetic field, is 45 degrees. So we're going to have to actually use the right-hand rule here. It will help us. So we got B in the direction of my middle finger, V in the direction of my pointer finger. And we can see that my thumb here is kind of pointing into the board. And we can say along the y-axis here, perhaps, from the way I've drawn the axes. So we can conclude that the direction of the force is along the y-axis or into the board, which is along j hat, because the problem asks for the answer in component form. So now we can go over to the equation over here, where we have F equals Q V cross B. We look at V cross B again, where it's the magnitude of the two vectors times the sine of theta. And we know that theta was given, and so are V and B. They're the same for parts A and B of this problem. So we have our full equation here, and we can go and just plug our given values in. For Q, 1.6 times 10 to the negative 19th coulombs, the charge on a proton. The given velocity of 1 times 10 to the 7th meters per second. The given magnetic field of 0.5 teslas, and then times the sine of the angle between the velocity and the magnetic field vector, which is 45 degrees. And we plug it into our calculator, and we get 5.66 times 10 to the negative 13th newtons in the j hat direction, which we already determined that it would be in the j hat direction. So writing it in component form, it would be something like 5.66 times 10 to the negative 13th j hat newtons.